Hi, in this lesson, we will be simplifying expressions with rational exponents. Remember, a rational number is a fraction. So basically, we will have exponential expressions where your exponents have fractions or are fractions. And we will also be simplifying radicals that are more than just square roots. So we'll be simplifying cube roots, fourth roots, fifth roots, etc. Okay, so let's start with simplifying expressions with rational exponents. And in order to simplify these expressions, we need to recall some rules we learned in Module 10. So the first rule says that any expression raised to the zero power is 1. The second one says that if you have two exponential expressions with the same base, and you're multiplying, you actually add the exponents. Third one says that if you have an exponential expression raised to another power, you multiply the exponents. Fourth rule says that if you are dividing an exponential expression by another exponential expression with the same base, you subtract the exponents. So you subtract the exponent in the numerator minus the exponent in the denominator. The fifth and sixth rules are similar. So basically, you have to remember that you can never leave negative exponents in your final answer. So if you have x to the negative n, you rewrite that as 1 over x to the positive n. Or if you have a negative exponent in the denominator, like in Rule 6, so 1 over x to the negative n, you correct for that by bringing the x up, and the exponent changes to positive, so it equals x to the positive n. All right, so we're going to use all of those rules to simplify the following expressions. And remember, some or all of your exponents will be fractions. So here's the first one. We have x to the 1/2 times x to the 3/2. Here we're using rule number 2, which means we have to add our exponents. So the work is here on the right, because if I'm adding two fractions, you can't add fractions unless they have the same denominator. So the LCD for 2 and 5 is 10. You multiply the first fraction, 1/2, by 5 to get 5/10. Multiply the second fraction by 2 on the numerator and denominator, and you get 6/10. So the sum is equal to 11/10. So you want to always leave your fractions as improper fractions, not as mixed numbers, but just make sure they are simplified. So 11 and 10 have nothing in common, so you can't simplify them, but do not write it as 1 and 1/10. So you don't want to have mixed numbers in an exponent. That looks strange. So your final answer is x to the 11/10. Okay, so now we move on to the second example. I have y to the negative 14 raised to the 3/7. This is rule number 3. So that means I have to multiply the two exponents. That's the work you see here. So I have negative 14, I'm writing it as a fraction, as negative 14 over 1 times 3/7. That simplifies because 7 goes into itself once, goes into 14 two times, and negative 2 times 3, because this is negative, is negative 6. But we know that we can't leave negative exponents in our answer, so you rewrite this as 1 over y to the positive 6. Okay, here's another one. Again, we're using rule number 3 first, but I have two variables. So I need to multiply 2 times 1/6 and negative 3 times 1/6. So that work is here. So 2 times the 6, 2 goes into 6 3 times. So the first exponent for a is a to the 1/3. And then negative 3 times a 6, 3 goes into that 2 times, so you get negative 1/2 as my exponent for b. So the second line says that this is equal to a to the 1/3 times b to the negative 1/2. But again, I have a negative exponent associated with the b, so the b goes into the denominator below a, and the exponent changes to positive, so your final answer is a to the 1/3 over b to the 1/2. Okay, so let's move on. Here I have a to the 1/3, 8 to the 1/3. So what's different about this example is that I don't have a variable, I just have a number as my base. So I can't multiply 8 and 1/3, but I can rewrite 8 as an exponential expression. 8 is 2 to the 3rd power because 2 times 2 times 2 is 8. And now that I write it like this, I can use rule number 3 because I can multiply my exponents. 3 times 1/3 is 1, so 2 to the 1st power is just 2. And that's your answer right here. I'm going to do the same or something similar in number 5. But in number 5, I have a negative exponent. So the first thing I did was I rewrote it without a negative exponent as 1 over 16 to the positive 1/2. And then again, I need to rewrite the 16 as an exponential expression. So 16 is the same as 4 to the 2nd power raised to the 1/2. And now I can multiply my exponents. 2 times 1/2, my 2 exponents, this is rule number 3. 2 times 1/2 is 1, so you end up with just 4 in the denominator, so your overall answer is 1/4. Okay, here's another one. I have 32 to the 3/5. 32 can get rewritten as 2 to the 5th power, because 2 times 2 times 2 times 2 times 2, 5 times is 32, raised to the 3/2. Then you multiply these two exponents, so 5 times 3/5, the 5s cancel, so that's equal to 3, so that's why we see 2 to the 3rd here. And 2 to the 3rd power, well, that means you multiply 2 3 times, and that gives me a value of 8. Okay, so in this example, number 7, I have a combination of coefficients and variable expressions. Okay, so the first thing I'm going to do is rewrite 64 in a different way as 4 to the 3rd power. 4 to the 3rd power is 64, so similar to the last 3 examples I did. Everything else I just copied down, haven't changed anything in that second line other than to write 64 as 4 to the 3rd power. Then in this line, I multiplied all of my exponents here with 1/3. So 3 times 1/3 is just 1, so that's why I just get 4 to the 1st power. 3 times 1/3 associated with a, that's also just 1, so that's why I just get a there. And then negative 9 times 1/3, well, that's negative 3, so it's b to the negative 3 power. Second expression is the same, hasn't changed. Okay, so now I have to use rule number 2 because I'm multiplying two expressions. So I can multiply my numbers 4 and 2, but I add my exponents. So here you see 4 times 2 is 8. A to the 1st and a to the 5th is a to the 6th. B to the negative 3 and b to the 1st, that's b to the negative 2. So my final step is to correct for that negative exponent. So b goes into the denominator below 8 to a to the 6th. And the exponent changes to a positive 2. So your final answer is 8 a to the 6th divided by b squared. Okay. So here's another part of this lesson. So every expression with a rational exponent can be rewritten as a radical. So in other words, if I have an exponential expression here, x to the m over n being the fraction, that is the same as saying the nth root of x to the m. Notice that the denominator becomes the root. When n is 2, it is a square root. And when it's a square root, you simply do not write the little 2 in the corner. So all of the problems that we've done with radicals up to this point have been square roots. So when I had to take the square root of 4, I knew that was 2, but I didn't put the root here in the corner. Same thing when I had to take the square root of 9. We know that's 3, but I didn't put the little 2 in the corner. It's just not necessary. It's it's implied when you don't have the root there that it is a square root. But all other roots, cube roots, fourth roots, fifth roots, you have to put the little number in the corner. Okay, so the denominator is what we call the root. The rest of the expression is what we call the radicand, and the radical symbol is what's letting you know what operation you're doing, and that's this. It kind of looks like a division bar, but it's not because it has like this little tail. Okay, so we want to rewrite each expression as a radical. And again, we're just using this rule that's above. So I have x to the 3/5. Remember, the denominator, which is 5, becomes the root. So this is read as the fifth root of x cubed. Here's another one, a to the 1/2. The denominator of the rational exponent is 2. That means it's a square root. So you just write that as square root of a. Right? You don't have to put a to the first power. Again, the square root and to the first power are implied. Here's number 3. I have x plus y to the 3/4 power. The denominator is the root of the radical. So that becomes the fourth root of x plus y to the third power. Okay, you need the parentheses for x plus y because the whole thing is raised to that exponent. Okay, same thing here. This is similar. I have 5a to the 1/2. That means both the 5 and the a go inside of the radical. We don't write the 2 in the corner of the radical because it is a square root and it's implied. Here I have 7x to the 1/3. Notice that the exponent only belongs to the x. So only the x goes inside of the radical. 7 becomes a coefficient. So we get 7 cube root of x. And then my last example, I have xy to the 2/5 power. The 2/5 power belongs to both the x and the y. So this will be the fifth root of xy to the second. You could also write it like this. If you multiply that 2, you could also write this as the fifth root of x squared, y squared, and they mean the same thing. So that just means I squared the x and the y. Okay, now we want to go in the other direction. Let's rewrite each radical as an exponential expression. We're again still using the same rule. So the first example is the square root of 3x. That means the 3x belongs to whatever the exponent should be. Since I don't see a root in the corner, I know it is a square root, so this is equal to 3x in parentheses raised to the 1/2 power. Okay, for number 2, I have 4 times the fifth root of y squared. So the 4 is not inside of the radical, so the exponent only belongs to the y. So this is 4y to the 2/5. Do not put parentheses around 4y. It would mean something different if you had parentheses around it. If it looked like I did here with the parentheses, that means the 4 would have been inside of the radical. Okay, so you want it without the parentheses, and it's just 4y to the 2/5. Okay, here's another one. I have the fourth root of x plus y cubed. Well, that one should look familiar. We just did that here. So that's the same as x plus y to the 3/4 power. And then finally, our last one, I have the cube root of 4x squared. This time, both the 4 and the x squared are inside of the radical. So it will be 4x squared to the 1/3. This means also the same thing as 4 to the 1/3 and x to the 2/3. So that would be another way to write it. And basically all I did was multiply each exponent by 1/3. Remember, 4 is the same as 4 to the first power, so that's 4 to the 1/3. Okay, let's move on. So now we're going to simplify radicals that are not square roots. So we need to remember what we know about radicals. You're looking for a perfect root. So whatever the root is, you're looking for a number that multiplies by the same number of by the same times as the root. So in this case, I'm looking for a number that I multiply, the same number that I multiply 3 times to get 8. Well, that would be 2. And that's because 2 times 2 times 2 is 8. So we move on to the second one. I want to evaluate the fourth root of 81. The fourth root of 81 is 3, and that's because 3 to the fourth power, which is 3 times 3 times 3 times 3, we know that that's 9, and that's 9. 9 times 9 is 81. So the more you practice these, the more familiar you get with these types of numbers. Okay, so now I'm back to another cube root. I have 27. The cube root of 27x cubed y to the 6th. So here I have variables. So first let's talk about our coefficient. 27 is a perfect cube. And the cube root of 27 is 3. So that's why you see 3 here. And regarding the exponents, well, it's the same as with square roots. Remember, with square roots, if I wanted to simplify x squared y to the 6th, you just get xy cubed, because my exponents get divided by 2. Here, your exponents will get divided by 3, which is the root. So I get x to the first power, and 6 divided by 3 gives me y squared. Okay, so now we move on to number 4. Number 4 is asking for the fifth root of 32, a to the 5th, y to the 11th. All right, so 32 is a perfect fifth root, because 32 is the same as 2 to the 5th power. A to the 5th is a perfect fifth root because the 5 is divisible by the root of 5, but y to the 11th has to be broken down. And so we want to break it down into expressions where the exponent is divisible by 5. So the number closest to 11, without going over, that's divisible by 5 is 10, and y to the 10th times y is y to the 11th. Okay, so now I'm ready to take the fifth root of everything that's perfect. So the fifth root of 2 to the 5th is 2. That comes out. Fifth root of a to the 5th is a. That comes out. Fifth root of y to the 10th, well, 10 divided by 5, that gives me y squared. That comes out. And I only have the fifth root of y inside the radical. Let me split this up a little bit. So the y is squared, but the radical is fifth root. Okay, so here's another one, number 5. I have the fourth root of x to the 5th, y to the 9th, z. So the 16 can get rewritten as 2 to the 4th power. X to the 5th has to get broken down into x to the 4th times x, again, because you want exponents that are divisible by 4. And the same thing has to be done with the y. Y to the 9th gets broken down into y to the 8th times y. You can't break down z more than it already is, so you just write down z. Okay. The fourth root of 2 to the 4th, or 16, is 2. That comes out. Fourth root of x to the 4th is x. That comes out. Fourth root of y to the 8th is y squared. That comes out. And then I'm just left with the fourth root of xyz inside the radical. Don't forget to put the root in the corner. Your homework system will definitely flag it as wrong unless the root is there. Because then it will assume it's a square root, and this is not, it's a fourth root. Okay, here's another cube root problem. I have the cube root of 54, m to the 6th, n to the 13th. Okay, so 54 is not a perfect cube, but 54 can get rewritten as 27 times 2. And the reason why we like 27 and 2 is because 27 is a perfect cube. M to the 6th is a perfect cube, and we know that because the 6 is divisible by 3. But we do have to break down n to the 13th as n to the 12th times n, so that my exponent is divisible by 3. So now the cube root of 27 is 3. That comes out of the radical. Cube root of m to the 6th is m squared. That comes out of the radical. Cube root of n to the 12th, 12 divided by 3, that gives me n to the 4th. That comes out of the radical. And then you're just left with cube root of 2n still inside the radical. So that's it for that lesson. Please give it a try. Good luck.